This is last video about theoretical part of biphasic system where we will learn DLVO theory. Okay. Before moving to DLVO theory, let us revise the theoretical part which we have already learned about biphasic system. In biphasic system, two phases are there: dispersion medium, in which dispersed phase is uniformly dispersed. Okay. We expect that dispersed phase should remain dispersed, correct, and there should be no aggregation. So when the dispersed phase is well dispersed, it is thermodynamically unstable. Okay, and that thermodynamical instability is given by Gibbs free energy, which is equal to gamma delta A. Delta A is increase in surface area of dispersed phase and gamma is interfacial tension. So due to the interfacial tension, as interfacial tension increases, dispersed phase will remain dispersed, correct. Now this is thermodynamically unstable but kinetically stable. So when you say kinetically stable, it means that particles or globules are away from each other. Okay. Now another point we learned that these particles can remain away from each other due to electrical double layer or electrical potential. We call it as surface potential. Now this surface potential is due to the aggregation of charge. Okay, it is due to crowding of the charge at the surface, and then electric double layer will be formed, that is stone layer and then diffuse layer, and the bulk will be electrically neutral. If you measure potential from the surface of dispersed phase to the diffuse layer, it is called as Nernst potential, correct, which we are not interested in practically. But if you determine the potential from stone layer to the diffuse layer, it is called as zeta potential. Okay, and we need some minimum zeta potential which is required for repulsion of particles from each other. If particles repel each other, there will be no aggregation, and this aggregation might be called as flocculation. Floccule means what? Floccule means loose aggregation. After shaking, it will disperse again. That is called as flocculation. And another term is coagulation. Coagulation means strong attraction. Okay, it will form the strong cake. It is very difficult to redisperse. So in pharmacy practice, we need flocculation. In pharmaceutical industry, we do not expect coagulation, we expect flocculation. Now let's move ahead and go to the DLVO theory. Okay, now you see the minimum zeta potential required for particles to repel each other is called as critical zeta potential. This is first point you will note in your notebook. What is critical zeta potential? It is the minimum zeta potential required, okay, to maintain the repulsion between particles. Clear? Now another point, this based on this electric potential and electric double layer theory, okay, a rule was formed, that is Schulz-Hardy rule. You should write in the notebook, Schulz-Hardy rule. Okay, Schulz-Hardy rule says that if you add electrolyte to the dispersed system, to the biphasic system, if you add some electrolytes, okay, then these electrolytes, okay, may neutralize the charge. These electrolytes may neutralize the charge on the surface, and then there will be no repulsion in between particles and particles will aggregate. Okay, this aggregation according to Schulz-Hardy rule, okay, is directly proportional to the valence. Means what? If you want to aggregate this suspension, means you want to break the suspension. Breaking of the suspension means particles aggregation will occur and suspension will break down, correct. If you want to break the suspension, then power of breaking of suspension Na plus se zyada, you will have Ca plus plus. Ca plus plus se zyada aluminium plus plus plus. I hope you are getting my point. Okay, so what is Schulz-Hardy rule? Schulz-Hardy rule says that electrolytes may neutralize the surface charge and aggregation may occur. This aggregating power increases with increase in the valence of the electrolyte. Clear? The same way Cl minus se zyada power rahega SO4 minus minus and so on. Now the another rule is Hofmeister series. You should write in the notebook, Hofmeister series. Okay, now what is Hofmeister series? Hofmeister series says that if you keep valence constant, then aggregation power increases as size of the ion increases. For example, if I add Na plus ions to this and aggregation is occurring. Why aggregation will occur? Because surface charge will be neutralized. If surface charge is negative and if I am adding Na plus, surface charge will be neutralized and particles will have no repulsion. There will be no zeta potential, correct? And they will come closer and they will attract and they will form coagulate. So Hofmeister series says that now Na plus, then K plus, okay, then Cd plus, cadmium, okay. Now you see, or H plus I say, okay. So Schulz-Hardy rule says that valence 1 1 1 है तो उसका power तो same होना चाहिए, but Hofmeister series says that it is not like that. Okay, Na plus से ज़्यादा power K plus का है, K plus से ज़्यादा power Cd plus का है, cadmium का है. Okay, so accordingly, if you have magnesium plus plus, so उससे ज़्यादा power और किसे आयन करेगा, जो जिसका वैलेंसी प्लस प्लस ही है लेकिन उसका साइज बड़ा है. So this series of valence 1 is called as Hofmeister series. Okay, this is second Hofmeister series. So Hofmeister series says that aggregating power of electrolyte or ion increases as size increases. Understood the point? Now, based on Schulz-Hardy rule, okay, and this Hofmeister series, based on this knowledge, group of scientists, two groups of scientists, okay, or two pairs of scientists developed a theory. That theory is known as DLVO theory. Okay, so scientists' name were Darjagwin. This is Indian pronunciation, Marathi medium pronunciation, I will say. Okay, so I am very sorry if pronunciations are wrong. Okay, but if you are good at that, please correct me on WhatsApp group. I will accept it. Okay, it will be my pleasure if you suggest. So Darjagwin and Lanju. But of course, scientific knowledge is more important than your language. Correct. See, in China, patents are written in Chinese. In Japan, in Japanese. Correct. In France, in French. In Germany, in German. In US and UK, in English. And we are Indians, we write our patents in English. So the whole world can understand our patents. But if you want to read Chinese patent, then you have to use translator. And the translator is the Chinese person who knows good Chinese as well as English. And Google translation, of course, it is available online. But still you miss something during translation. Are you getting my point? So science is the most important thing. Okay, not language. Of course, language is important to convey it. Okay, so Darjagwin and Landu. So why I am telling all this? Because if your language is not good, you don't worry. Okay? Science is all about imagination and thinking power. So if you are good at thinking, okay, if your aptitude is good, after all, what is GPAT? Graduate Pharmacy Aptitude Test. What is aptitude? Aptitude means thinking ability. If your thinking ability is good, no, then you will go ahead. No problem at all. Correct? Languages can be learned afterwards. Thinking ability, development of aptitude takes long time. बराबर? Vocabulary तो रोज बढ़ती रहती है. आप 4 movies देखोगे तो आपका vocabulary अलग बनता है. You see different series, correct? कुछ thriller देख लिया तो अलग words पता चलते हैं. Romantic series देख लिया तो कुछ अलग words पता चलते हैं. That is the language. Language can be learned. But जापान में आप जाओ, जापान में 10 साल रहो, वहाँ पे आप सीख जाओगे जापानीज. आप कोरिया में रहो 5-10 साल, आप सीख जाओगे. Our students are there in Korea, Japan, in different places. They learn that language, correct? But this thinking ability you should develop. That is the purpose of education. Okay? So come to the point. Sorry for deviation. Darjagwin and Landu, they worked together and they developed a theory. Why they developed the theory? They developed the theory to understand factors affecting stability of dispersion or stability of biphasic system. Now biphasic systems can be divided as lyophilic system and lyophobic system, correct? Lyophilic and lyophobic. Now this lyophobic system was studied by Darjagwin and Landu. Darjagwin और Landu ने ये सिस्टम स्टडी किया, इसका स्टेबिलिटी स्टडी किया. लायोफिलिक का क्यों नहीं स्टडी किया? लायोफिलिक का इसलिए नहीं स्टडी किया बिकॉज लायोफिलिक आर यूजुअली स्टेबल एंड देयर इज अ इलेक्ट्रिक डबल लेयर थियरी, देयर इज हॉफमेस्टर सीरीज, देयर इज शुल्ज-हार्डी रूल ऑलरेडी देयर. सो जो नहीं था इसके बारे में सोचने का जरूरत था. इसके बारे में तो सब हो गया अभी बिकॉज लायोफिलिक में ही वो आयोनाइजेशन वगैरह होगा. आर यू गेटिंग माय पॉइंट? सो व्हाट अबाउट दिस लायोफोबिक सिस्टम? सो स्टेबिलिटी ऑफ लायोफोबिक सिस्टम was studied. Okay, you should write in the notebook. Stability of lyophobic system was studied by Darjaguin and Landau, and independently by other pair also, that is VO. Okay, that is Verwey and Overbrick. So Verwey and Overbrick, they also studied the same thing, different place. Okay, independently. They were not having WhatsApp group and chatting and emails at that time. Okay, so when they published, Darjaguin and Landau published, Verwey and Overbrick published. Then they understood that it is like same, and they combined it, and it became DLVO theory. DLVO theory. So what is DLVO theory? DLVO theory explains factors affecting stability of lyophobic system, and we are interested in stability. Which stability? Kinetic stability. Okay, we want them dispersed. We do not want aggregation. Now, what is this DLVO theory? This DLVO theory says that. Okay, now we are starting with DLVO theory. You should give the title. Okay. DLVO theory can be understood by diagram. See, there are two main forces, major forces. एक होता है repulsive force, दूसरा होता है attractive force. अपने को repulsive force कम चाहिए कि ज़्यादा चाहिए? Kinetic stability के लिए ज़्यादा चाहिए. So I will write here repulsive force, VR, repulsion, potential energy of repulsion. ठीक है? Now another is attractive force. Attractive force कम चाहिए कि ज़्यादा? कम चाहिए. Attraction नहीं होना चाहिए particle में. So that is potential of attractive force. Clear? Now, this x-axis is interparticulate distance. Interparticulate distance. ठीक है? तो ये 0 है यहाँ पे, बराबर है. Now you see, जैसे आप ऊपर से नीचे आएंगे, रिपल्शन कम होते जाएगा. ओके, अभी यहाँ पे रिपल्शन 0 हो गया, तो यहाँ पे अट्रैक्शन थोड़ा बढ़ गया, यहाँ पे अट्रैक्शन और बढ़ जाएगा. तो यहाँ पे हाई अट्रैक्शन है, ज्यादा अट्रैक्शन है, मोर अट्रैक्शन. यहाँ पे लेस अट्रैक्शन. आई होप यू आर गेटिंग इट. अंडरस्टूड? यहाँ पे लेस रिपल्शन, यहाँ पे हाई रिपल्शन. आई होप यू अंडरस्टूड दिस स्केल. सी, हाई रिपल्शन कम होते गया, 0 हो गया रिपल्शन, थोड़ा सा अट्रैक्शन, थोड़ा अट्रैक्शन बढ़ते जा रहे हैं. तो बॉटम में यहाँ पे पॉइंट मिलेगा तो ज्यादा अट्रैक्शन है. समझ में आया ये चीज? ओके, नाउ दिस इज पार्टिकल डिस्टेंस. Okay, so I will draw it here. So these particles are away from each other. ठीक है? And here particles are closer to each other, and particles are very close to each other. Like this. Clear? Now you see. So this is the case. Particle distance is high. Particle distance थोड़ा कम हो गया. This is the case. Particle distance एकदम कम हो गया. This is the case. Clear? So this is called as agglomerate. इसको क्या बोलेंगे? Agglomerate. इसको क्या बोलेंगे? Floccule. Floccule मतलब loose aggregate. Loose aggregate होता है, जो थोड़ा सा शेक किया तो डिस्पर्स हो जाता है. Okay, floccule. And these are separated dispersion. So this is ideal case. ये नहीं है तो कम से कम ये सही, लेकिन ये नहीं होना चाहिए. Coagule नहीं होना चाहिए. Understood the point? Now you see. If dispersed system has no attraction at all. Why? Because they have like charges on their surfaces. So if they have minus charges, then they will repel each other. So what is the effect of distance on that repulsion? That we will learn. Okay, so that will be, you see, if distance is very, very less, repulsion will be high. Clear? If distance is very, very less, that repulsion will be high. Now, as you increase the distance, means as you take particles away from each other, that repulsion will decrease. So what this line indicates? It indicates that as interparticular distance increases, okay, repulsion decreases. Why? Because particles are going away from each other. बराबर है? So this is the case only when there is no attraction between the particles. Now, when there is attraction between the particles, okay, then what is the case? When there is attraction between the particles, high attraction will be there when particles are close to each other. Okay, but if particles are very much closer to each other, then they will repel each other, because you know the like you should not come so close कि repulsion हो जाए. I hope you are getting. So critical distance is there, no? So there is one Marathi poem that इतुके यावे जवळ जवळ की जवळपणाचे व्हावे अंतर. करेक्ट. जो इतना क्लोज नहीं आना है कि क्लोजनेस का ही डिस्टेंस बढ़ गया. तो बहुत नजदीक आने से भी कभी कभी डिस्टेंस झगड़ा हो जाता है, डिस्टेंस बढ़ जाता है. ओके. सो एट दिस डिस्टेंस इफ दिस इज द अट्रैक्शन, बराबर, थोड़ा सा डिस्टेंस बढ़ा लो, थोड़ा सा, अट्रैक्शन ज्यादा हो जाएगा. मीन्स गिव स्पेस टू ईच अदर यार. करेक्ट. आप अपने आपके पार्टनर को स्पेस नहीं देंगे तो फिर डिफिकल्ट हो जाएगा. और इसके बाद जैसे जैसे पार्टिकल डिस्टेंस बढ़ेगा अट्रैक्शन कम होते जाएगा. So this is the case. So this is the case when only attraction occurs between particles. There is no repulsion. Okay. It depends on chemical nature of the system. And this is VR. Now, actually the condition practically occurs is that in any dispersed system, usually only repulsion or only attraction is not possible. There is combination of attraction and repulsion. Repulsion occurs due to electric double layer. Okay. Electric double layer is there. Then it depends on the radius of the particle. It depends on the interparticular distance. It depends on dielectric constant of the medium. Okay. So that is what? That is repulsion. Now, attraction occurs due to van der Waals forces. Then van der Waals forces means dipole-dipole interaction that we will learn in physical pharmacy. So van der Waals attraction includes hydrogen bonding also, maybe. Correct. So ऐसे हो सकता है कि at a time attractive forces भी है, repulsive forces भी है. But as distance between particles will change, that attraction repulsion will change. For example, myself and my partner, okay, my friend, okay, we have attraction also, we have repulsion also. So when we come very close, we have repulsion. Okay, but थोड़ा सा close, we have attraction. Okay, एकदम दूर जाएंगे, बहुत ज्यादा attraction, no repulsion. I hope you are getting my point. So attractive forces भी है, repulsive forces भी है. Distance कितना है इसके ऊपर डिपेंड करता है. कभी कभी तो बहुत प्यार आता है यार, और कभी कभी वेरी डिफिकल्ट. सो मेनी मॉम्स माइट बी इरिटेटेड नाउ बिकॉज ऑल स्टूडेंट्स आर एट होम सिंस लॉन्ग. करेक्ट. बट इफ यू गो टू हॉस्टल, इफ यू गो जॉइन योर इंस्टीट्यूट एंड इफ यू डू नॉट कम एट होम फॉर 2 months or 6 months, देन बहुत प्यार आता है. करेक्ट. मम्मी बोलती है कि कभी तो घर पे आओ यार, 2 दिन के लिए कम से कम. तो उसको ऐसे होता है कि क्या खिलाऊं क्या नहीं खिलाऊं, क्या बनाऊं क्या नहीं बनाऊं, बेटा बेटी घर आई है, whatever it is. So there is a combination. So we will combine these two curves. ये जो 2 curves है इसको हम लोग combine करेंगे. Okay. तो जब combine करेंगे, you see, जब बहुत दूर है तो attraction बहुत अच्छा रहता है ना. बेटा या बेटी हॉस्टल पे है, बहुत दिनों से दिखी नहीं, तो attraction है, प्यार आ रहा है. बराबर है. करेक्ट. अभी बेटा या बेटी 6 महीने में एक बार घर आती थी तो बहुत ज्यादा प्यार होता था, अट्रैक्शन होता था. अभी थोड़ा डिस्टेंस क्लोज हो गया कि नजदीक का कॉलेज मिल गया एमफार्म के लिए, अभी तो 15 दिन में घर पे आते हैं. अभी अगर 15 दिन में घर पे आते हैं तो अट्रैक्शन कम हो गया, रिपल्शन आ गया है यहाँ पे, रिपल्सिव सिस्टम में चले गए. करेक्ट. अभी जब रिपल्सिव सिस्टम में चले गए, जैसे डिस्टेंस कम हो रहा है, अरे रोज ही तो आता ही है घर पे. करेक्ट. तो रिपल्शन तो बहुत ज्यादा है ना. कुछ लेना देना है, क्या खा रहा है क्या नहीं खा रहा है, तुझे क्या अच्छा लगता है, कोई रोज रोज थोड़ी ना पूछेगा आपसे. बराबर है. नाउ अभी ये डिस्टेंस बहुत क्लोज हो गया. ओके. इतना ज्यादा क्लोज हो गया कि ये अभी इतना क्लोज हो गया कि ये तो 2 दिन में घर आता था, अभी ये रोज घर पे रहता है. एवरी आवर ही नीड्स मॉम और डैड, और शी नीड्स मॉम और डैड. व्हाट इज द रीजन? द रीजन इज दैट यू आर सिक. आप बीमार हो तो एकदम क्लोज हो मम्मी पापा के, आप दूर ही नहीं जा रहे हो घर से. करेक्ट. काळजी वाढली, आता परत अट्रॅक्शन वाढलं. आई होप यू आर गेटिंग इट. करेक्ट. सो अभी और अट्रैक्शन बढ़ गया आपका, और अट्रैक्शन बढ़ गया, ये ऐसे होता है. आई होप यू आर गेटिंग माई पॉइंट. सो अट्रैक्शन रिपल्शन दोनों फोर्सेस है. कौन सा प्रीडोमिनेट करेगा डिपेंड्स ऑन इंटरपार्टिकुलर डिस्टेंस. सो बहुत दूर है तो थोड़ा अट्रैक्शन तो है, अच्छा अट्रैक्शन ही. करेक्ट. लेकिन थोड़ा नजदीक आना चालू किया तो रिपल्शन होने लगा यार. कि मम्मी पूछती नहीं है तेरे को क्या अच्छा लगता है, उल्टा सुनाती है कि ये खाना ही पड़ेगा तुझे. बराबर. लेकिन जब और डिस्टेंस और ज्यादा क्लोजनेस आए कि आप रोज ही घर पे रह रहे हो क्योंकि आप बीमार हो, बहुत ज्यादा डिस्टेंस क्लोज हो गया, तो अभी तो रोज पूछती है तुझे ये अच्छा नहीं लगता है, तो मैं जो अच्छा लगता है वही बनाऊंगी. बराबर. तो यहाँ पे और डिस्टेंस क्लोज हो गया. बराबर. यहाँ पे बहुत ज्यादा अट्रैक्शन. आई होप यू गॉट द पॉइंट. बराबर. और वापस ये उल्टा जाएगा क्योंकि आप बीमारी से उठोगे और स्टिल आप घर पे ही रहते हो, फिर वो कुछ नहीं, फिर रिपल्शन वापस चालू होने वाला है कुछ देर के बाद. I hope you are getting it. Okay, so this is the summation of VR and VA. Okay, 2 curves are summation is there. So you see, this is called as secondary minimum. Okay, sorry, this is called as primary minimum and this is called as secondary minimum. I will write here. I hope you are getting it. This is primary minimum of the curve. Okay, this is secondary minimum of the curve. Now you understand secondary minimum में क्या हो रहा है? Secondary minimum में attraction हो रहा है. These are attractive forces. And primary minimum में क्या हो रहा है? Sorry, primary minimum में भी attraction हो रहा है. Secondary minimum में भी attraction हो रहा है. Now आप मुझे बोलो attraction कहाँ पे ज्यादा है? Floccule में कि agglomerate में? Agglomerate में tightly packed. शेक किया तो भी डिस्पर्स नहीं होगा. So agglomerate में बहुत ज्यादा attraction है. यहाँ पे high attraction. So what is this primary minimum? It corresponds to agglomeration of particles, which is not desired. Okay. Now secondary minimum corresponds to flocculation, which is desired. थोड़ा सा attraction है, अच्छी बात है. थोड़ा शेक किया, वापस दूर हो जाते particles. Okay, understood? Clear? Now this repulsion we need, not in personal life, but we need this repulsion in dispersed system. You know, family should not be dispersed. Family should be like agglomerate, but suspension and emulsion should be well dispersed. Correct? So we need this. So this is called as energy barrier, VM, barrier of minimum energy or minimum potential required. Correct? At least this much potential should be there. इतना repulsion तो बनाए रखना चाहिए यार. Okay. So flocculated system है तो ये ठीक है. Otherwise फिर ये ठीक है. So this distance is maintained. This potential is required. Okay, to keep them repelled from each other. And this is due to zeta potential. This repulsion is due to zeta potential. Understood the point? Clear? So what we learn? We learn DLVO theory. What is DLVO theory? It says that there is primary minimum, okay, when particles are very close to each other. As distance increases, repulsion increases. Then again repulsion decreases as distance increases. And when you go much away from each other, then again there is somewhat attraction which gives the flocculation. That is the graph. That's it about DLVO theory. I hope you understood. Now, concepts are, of course, all concepts are always important. You cannot say this is not important, that is important. Everything is important in science. If you work in nanotechnology, if you work in nanodispersion, these concepts will be useful to you. But for GPAT, just single liners are there which we have already written in our study material and you have already written in your notebook. Correct? Because GPAT will not ask you to explain the theory. That's it. But it doesn't mean that we should not be aware with the theory. We should be aware with it. Because after qualifying GPAT, when you will go to the good institute, when your professor is highly qualified and well equipped with the knowledge, then he will expect the same thing from you. Okay? And we should not lag behind in case of the knowledge. Understood? So draw this nicely in your notebook. That's it. Okay? Don't waste your time in writing only. You understand the concept and go to the next point. Thank you. Here we close theoretical part of biphasic system. In next new session, we will learn suspensions. Then in another new session, we will learn emulsions. Thank you.